new episode. The last time we learned how to insert a new node at the beginning or at the end of a list. Today we will learn how to delete a node from the head or from the end of a linked list. So now we have this list here. I want to remove this node, and this should be the head node. So again, we come to the linked list class and we create another method to delete from the head of the list. Public void delete from the head. So we don't need any parameter. Whenever we call this method has to delete the first node in the list. So again, first of all, we have to visually understand what the process looks like. So right now it is the first node, the head. So when we say that we are deleting this, that means we are trying to make this one as the head of our list. And what does that mean? That means the head has to point to this node instead of pointing to this node. So that's very easy. We just directly say that head has to point to the. So right now it is the head. But after this time, we say head equals head dot next. As easy as that. Because right now, when head stores this address, that means head is equal to this one. So after this time, you say that head has to point to the next node of current head. And the current head is this one. So the next one is the head dot next. So, and one thing more, you should know that most of the time when you delete an element from the list, you need to return that. You may print that. So now the value, the data type of all these values are integer, so you make it integer. And now before deleting that one, let's keep that the removed node in a separate variable. We say node of removed node equals head. So right now you stored the head in the removed node, and then you made the pointer of head to the head dot next. So after this time, you can return removed node dot data like this. Here's all it takes to remove a node from the beginning of a list. As soon as here you say that head equals to head dot next, so right now it is the head, and when we say that head has to point to the head dot next, that means the second node becomes the first node in the list. And in Java there is another concept you will study under the name of garbage collector or garbage collection. The garbage collector will take care of all these nodes which are not part of our list. And the garbage collector check as far as no other node is pointing to this node, that means this node is not part of any list, so they remove that from the memory. So it was how you removed a node from the beginning of the list. Now let's learn how to remove a node from the end of the list. So let's create another method for that. Public void delete from the end. So again, you don't need to pass any parameter. Whenever you call this method, it has to remove the last node in the list and take care of everything. So again, similar to adding a node at the end, when you remove a node at the end also, the most important point is to find the last node. And how you find that? Well, you have to start going through the list from the head list, from the head of the list, because you only directly access the head of the list through the head. So very similar to adding a new node, that when you started from the head and came to the last node, how did you recognize that? You came to a node that its next property was null. Then you said, well, you found the last node, and then you met that last node to that its next property has to point to the newly created node. So similarly, when you remove that also, you have to start from the head and find the last node. How you find that? Well, when you come to a node that its next property is null, then you say it is the last node. However, the point is that when you remove the last node from the list, you need the second last node to point to null. So when you find this, the last node, like checking its next property, but the point to remove this is that its previous node has to point to null, something like this. So now think, if you use one iterator, like we said current in the in earlier process when adding or inserting the new node at the end. So when you were on the last node, you could easily point to its next property to the new node. But now when you are here, when the current is here, you need its previous node that has to point to null. So that means we need one more iterator here. So each time we have to follow the current and its previous, because when the current comes here, it finds that it is the last node. When it is the last node, its previous node is here, so you have to keep the track of the previous node also. So here the previous node helps us, and it says that, well, its previous node has to point to null. That means we are removing this one from the list. So let's say delete from the end. So we should node current equals to head and node its previous. So right now it is null. When we start from here, current is here pointing to the head, and previous points to null at the moment. It is somewhere here. Let's think it points to null. So now let's start checking every node in the list, and start from the head. So you say while current dot next is not null, you keep going ahead, and each time, so when you check that the current.next is not null, so that means you have to move forward. For example, at this point you check that is current.next null. It says no, it is not null, it points to a node. So you say, well, then let's go to the next node. So you make current equals current.next, like this. Current comes here, and you make the previous follow the current node. So you make previous equals current. Now actually first make current equals previous equals to current. Right now current is here. And you check, is current.next null? At this point, is current.next null? No, it is not null. So if it is not null, then you say then you store this into the previous. You say, well, previous come and take this one, and when you store the current in the previous one, then you move current one step ahead at this point. Now it looks like this. At this point it looks like this. The previous holds the value of current, and then current itself jumped to one step forward. So the loop continues. When current is here at this time, is current.next equals to null? Again it says it's not null. Then again you say, well, so first previous comes here, and then you take current one step forward. Current equals current.next. So far it is like this. So at this point again, is current.next null? No, it is not null. So if it is not null, so you say previous come one step forward, and current also one step forward, current.next. So at this time you check, is current.next null? It finds that yes, it is null. That means we found our last node. So when we found our last node, then we check its previous node and make the previous node has to point to null, not to this last node. That is how we remove this from the list. So at this point we say, so at this point we come out of the loop and say previous.next points to null. So here when previous.next, instead of pointing to this node, points to null, that means this node is removed from the list. So I hope it was easy. So now as I said earlier, when we remove a node, we should return its value. So that's an integer. Let's make it integer, and at this point say, so it is the current. You have to return the current.value. Current was the node that we took out of the list, and now we just need its value. Return current.data. So it was how we removed a node from the end. I hope it was clear enough, and in the next lesson I will work one more example how to delete a node by value. And also how to print and how to search. Until the next time, have a nice time everyone.